Hello, everyone. This video is for CIS200 Unit 15 challenge work. So this is on page 15 of lesson 6. You would click launch activity in order to open it in Cengage, and then you would click start. As you see, I've already done that. So keep in mind, there's only 3 questions. They may be out of order, so please be sure that you are completing the proper one if yours are in a different order than mine. So this is the neural network question. As you can see, for time efficiency, I already have the table here completed. So we're going to walk through how this neural network trains itself to behave like a logical AND gate using our perceptron learning rule. We are picking up right where our initial adjustments left us with our weights sitting at weight 1, W1 equals zero point 0.4, W2 equals zero point 0.1, and our threshold theta at zero point 0.7. To kick off the next step, we input our final pair, 1 and 1. The weighted sum comes out to 0 0.5, which is less than our threshold of 0 0.7. So the network fails to fire and outputs a 0. Since our target was a 1, this triggers a corrective error of +1, prompting the algorithm to boost both weights and drop the threshold down to 0 0.5. Moving into Epoch 2, you can see the network successfully handles the first 2 cases with 0 errors. So we can see right here, Epoch 2, but now we have this third case. So whenever we hit the inputs 1 and 0, which we can see right here, the weighted sum reaches 0 0.6. Because 0 0.6 is greater than or equal to our threshold of 0 0.5, the neuron incorrectly fires, producing a 1 instead of a 0. This negative error causes the algorithm to dampen the weights and raise the threshold back up to 0 0.7. By the time we hit Epoch 3, look at what happens. The network handles all 4 binary input pairs perfectly, yielding an error of 0 across the board. So here's Epoch 3. We see our target, but we look at the errors, right, for Epoch 3, for all 4 of them, 0, 0, 0, 0. So in conclusion, because the error remains at 0 for the entire cycle, the algorithm stops adjusting. The network has officially finished its training, leaving us with a final working configuration of, we can see it right here. Of course, it's the same, but it was actually achieved at the last iteration of, the last, second to last iteration of Epoch 2, where the final adjustment happened. And then from the last iteration of Epoch 2 and all the iterations of Epoch 3, we have our final weights and theta. So we can just say W1 equals 0 0.4, W2 equals 0 0.3, and then you can just call it threshold or theta. I'll call it theta. We'll call it theta threshold equals 0 0.7. That is it. You would save this for as a document, convert it to a PDF, and then submit that PDF. And now we're going to move on to question 2. So this question 2 is pick one of the technologies and write a mini report like we've done several times before. So I'll just call it a technology report. So we can write about, I'm going to write about swarm intelligence and telecom routing. So swarm intelligence modeled after the collaborative behavior of ant colonies has revolutionized how modern telecommunications networks route massive data traffic. The core problem in these networks is dynamic congestion, where sudden spikes in traffic can overload specific servers and drop calls or s- slow down internet speeds. To solve this, to solve this, companies deploy ant colony optimization. Ant colony optimization algorithms where digital agents mimic ants leaving pheromone trails on the most efficient pathways through the network grid. As thousands of these digital ants explore the network, they dynamically update routing tables in real time to steer data packets away from congested areas. That would be enough, just a couple sentences, right? Doesn't have to be a full-on multi-paragraph, multi-page research paper, just to get your point across for your chosen technology. So save this for your documents, convert it to a PDF, and then go ahead and submit that PDF in Cengage. Now we're moving on to question 3, and this is the Chinese room argument. So the first part wants a description of the Chinese room argument. So the Chinese room argument is a thought experiment designed by philosopher John Searle to prove that computers merely manipulate symbols without actually understanding them. He imagines an English speaking man who knows no Chinese locked in a room locked in a room with a database of Chinese characters and an English rule book, which is the program that tells him exactly how to pair input symbols with output symbols. To someone outside the room, sliding questions under the door. The man's responses make him appear fluent in Chinese, passing the Turing test. However, the man is simply performing mechanical syntactic operations without understanding any of the Chinese language, proving that a program cannot produce genuine semantic comprehension. All right, now moving on to number 2. This is systems reply and evaluation. So systems reply and evaluation. So description of the reply. The system's reply argues that while the individual man inside the room does not understand Chinese, the entire system as a whole, which includes the man, the rule book, the room, and the database of symbols, does collectively understand the language. So the man himself may not understand the language, but the entire system which the man is a part of does understand the language. And then does it invalidate the argument? No, it does not seem to invalidate it. Cyril, the man who came up with it, Cyril effectively counters this reply by suggesting the man simply memorizes the entire rule book and internalizes the database. Even though the man is now the entire system and operates completely in the room, he still has no conscious awareness of what the Chinese symbols actually mean. He still has no conscious awareness of what the Chinese symbols actually mean, meaning syntax fails to create semantics. That will do it for question 3. You would save this document for your records, convert it to a PDF, submit the PDF in Cengage, and that completes Unit 15 challenge work. I hope that you found this video helpful. Thank you for taking the time to watch it. Have a great rest of your day.